Hello, so today we're going to discuss about the weekly Leetcode contest. So the first problem is Alice and Bob are playing a game and initially Alice has a string word A. You are given a positive integer K. Now Bob will ask Alice to perform following operation forever. Generate a new string by changing each character in the word to its next character in the English alphabet and append it to the original string. Okay. And for example, performing the operation on C generates CD means if the initial word was C, so the character next to C is D, so it generates the string CD. And similarly, if the string is Z and D, so the next character to Z that will be A. It is given that now note that the character Z can be changed to A in the operation. So the next character can be of Z can be A, and for B the next character can be C. So after appending the string will become ZVAC. So what we have to return is the value of kth character in the word after enough operations have been done for the word to have at least k characters. Okay, so this is very simple. You just have to do what the question says. So if we look at the constraints of this problem, they are very small. So if you look in this test case, like if k given to us is 5, and initially we know that the string that is given to us is a. So if we k equals to 5 and the word initially given to us is a, so if we look at the second next character of a, that would be b. So we can make our string as ab. Now, since AB is less than K, but we need the kth character, so we can perform this operation till we get our kth character. So, if our next string can be BC because the next character of A is B and the next character of B is C, so the string will become BC. And if you see first was A, then it became B, so the string together would be A, B, right? Now, after this, A can be B and B can be C. So, the concatenated string would become A, B, B, C, right? Now, since the length of string is still less than K because our K was 5, so again we can find the next character. So if we look at the next characters, then it would be B, C, C, D because the next character of A is B, the next character of B will be C. Similarly, the next character of B is C and the next character of C is D. So after appending this string B, C, C, D to A, B, B, C, our final string would be A, B, B, C and B, C, C, D. So, since this string has length greater than k, so we can find our kth character. So, if we iterate over the string, so we'll find our kth character equals to b. So, this will be our answer. So, now let us look at the code for this. It is simple that initially we have initialized a word string that is starting with A because it is given in the question. Next, we are applying a while loop that will run till our string length is less than equals to k, or you can say less than k. Now, at each iteration, we are building a new string. That new string would contain the new characters that would be the plus one of the previous characters. So, this is the for loop which will iterate over the current string. So, this will build a new string, and this condition is applied because we are given that if our current character is z, so after that simply a will come. So if our current character is Z, so next A will come and it will be appended to the new string. And at the last, our all the strings can be concatenated. So if and at the last we are returning our kth character, and it is done -1 because string runs on the basis of zero indexing like this. 3, 4. So if you can see that the here it can be 5, but through the string indexing it can be counted as 4. So therefore our answer would be B. So it was simple. Now if we look at the question number 4, it is similar to this problem. Just one condition is given, that we are given some operations array as well. If you look at the problem, if we read that now Bob will ask Alice to perform all operations in sequence. And what's the sequence is that if operation I equals to 0, then append a copy of word to itself. Okay. And if the operations I equals to 1, so we have to do the operation similar to the operation that we have done till now. Means the one we have done in the previous question. So in this case, what we have to return same, the value of the kth character in the word after performing all the operations. Okay, so you might think that this is easy and we can only iterate over the operations array and then we can perform our actions. Yes, we could do this, but if we look at the constraints of the problem, so here the constraints are k equals to 10 raised to the power 14. So in this case, we cannot iterate over the kth length and then we can find our kth character. It will give us a TLE. So what we can do? So for this, we need to think another approach. So if we take some test case, like if we take the first test case, that is k equals to 5, and the operations given is question 4. We'll do question 2 and 3 also, but since question 1 and 4 are similar to each other, so that's why I'm discussing question 4 first. So k equals to 5 and the operations array that we are given equals to 0, 0 and 0, right? So since we cannot iterate over k, so what we can do, we can iterate over this array, right? So if we calculate a length which would be less than equals to k's length, and how we can calculate? We can simply calculate this length by doubling the initial length. Like if we take initial length to be 1, initial length equals to 1, and I at each iteration over this operation array, we can double this length and we can perform this operation till our length is less than equals to the k's length. And what's the benefit of this? That simultaneously we can store a integer in which we can store the index of the operations array. What's the benefit of this? That we can get a index that uh, before this index only, like let's suppose this is 1, this is 2, and this is 0, this is 1, and this is 2. So we can get a index that before this index only we have our kth character. And after that, if we will get our length, and after that, what we can do, we can iterate in the opposite direction on the operations array, and we can find that if by initially we were doing in doubling, we were doubling the length. Now if we are iterating in the backwards direction, then we can find then we can divide the length by 2, and we can find, we'll divide the length by 2 at each iteration. And because initially we were doubling, now when we are going back, then we will divide. So, and we'll check that if our operations array equals to 0 or 1. If it is 0, let's suppose if our operation array I, let's suppose, equals to 0, that means we do not need to perform any action because it was simply the replication of the initial string. But if our operation array equals to 1, that means we need to perform some action, right? So in that case, what we can do, we can initially store any answer equals to 0, and if our operations array equals to 1, then we can increment this answer. What will be the benefit of this? That at last we'll get our count, that how many operations we have performed, uh, which were equals to 1, and if we'll simply add these operations into our initial character, that was a, so we can get our final answer. So if you look at the code, so you'll have a better understanding. Like in this, you will see if our initially k equals to 1, simple, so we'll simply return a. But if k is not equals to 1, then initially what we are doing, we are traversing over the operations array, and as I have said that we are doubling the length, and we are doubling the length till we get our uh, length which is greater than equals to k. And if we are getting our length which is greater than equals to k, then simply we are breaking out of the loop and we'll get our index. Now we are iterating in the backward direction on the operations array. And what we are doing, we are checking that if our k is greater than equals to length by 2, then only we will search for it. And if our operations I equals to 1, then as I have explained, if our operations array equals to 1, then only we have to perform some action, and simply the answer would be incremented. And we have done this statement because if our k is not in the first half, then it would be obviously present in the second half. So for this, we are decrementing the value of k because we haven't find our k till now, but in the second half, the k will be present. So therefore, the k will be decremented by the length by 2 value. And at each iteration, we are simply like initially we were doubling, now we are dividing the length by 2. And if at last we have traversed over operations array, at last we are just adding this shift value in the character A, and this modulus is done by 26 just to maintain the record. Like our shift can, because the constraints are very large, so our shift can be greater than 26 also. So since we only have 26 characters in English alphabet, so to maintain that record, we are just doing this operation. Now let us move to question number third, which is you are given a string word and a non-negative integer key. Return the total number of substrings of words that contain every vowel A, E, I, O, U at least once, and exactly k consonants. Okay. So firstly, we can see what a substring is. So substring is a continuous character of words in a string. Like in this, if we see A, E, O, U is a substring. But if you say that I, A, U, and U, this would not be a substring. And in this case, what a valid substring is, that if a substring contains uh, all the vowels, that is A, E, I, O, U, and exactly k consonants, then it would be a valid substring. So if we look at first test case, that is A, E, I, O, Q, Q, and the k given is 1. So in this case, you can see the answer is 0. Why? Because if we iterate over this string, so A, E, I, O, yes, and the next character is Q. But it is said that we need to have at least one vowel once. Means in a substring all vowels should be present. But in this you can see no U is there, so we cannot make a substring out of this string. So the answer is zero. And if we look at this test case, so you can see that if we start iterating from the zeroth index, so firstly we can see I vowel, E vowel, A vowel, O vowel, U vowel, and the K given in this test case was 1. And here the Q is a consonant, right? So, can this be considered as a valid substring? Yes, because exactly K consonant is there, which is Q, and all are vowels. Now, if we move forward, we could also consider this substring as well if our K was equals to 2, right? But in this case, it is not. So let's move forward. Now, if we start from this character and move forward, then from Q to U, it can be a second substring, right? Because exactly one consonant, that is Q, is there and all the vowels are present. Now, if we move forward again, starting from I, the next character, if we take this character and if we start moving forward, so if we go till Q, so this can be another substring, right? This one. So in this case, we can say we can have only three valid substrings because all these substrings were containing exactly five vowels and one consonant, which was equals to the length of K. So the constraints here are very small, that is 250 only. So what we can do, we can simply iterate over this string, the given string, we can simply iterate and we can have a count of the vowels and plus the consonant. We can check at each iteration that if our given character is a consonant or a vowel. So if our at last, like if like if we reach over here and at each iteration we can check that if our condition is met or not. What is the condition? That it should contain vowels should be greater than equals to 5, means each vowel should have at least one occurrence, right? And if also K consonants should be K. So consonants should be K. So if this condition is met, so our string would be a valid substring. So if we simply look at the code of this problem, so initially you can see that initially we have stored our vowels in some set. We can check at each iteration also, but this is a good practice. So next we have taken the length of the word in some integer n, and next we are iterating over the string. And here we are maintaining a set V also, in which we can insert our current vowel, so that we can see that if we have got the vowel equals to 5 or not, because we need to have at least five vowels. So for the second for loop, we are iterating over the word only, and at each iteration here, we are taking each character of the word. So if we are iterating over this string, so initially we are taking the character I in our ch variable, and we are checking that if this vowel is present in our if this ch vowel, or we can say ch character, is present in our vowel set or not. If it is present, so we'll simply insert it in this set, and if it is not, that means it is a consonant. So we'll simply increment our consonant size. And at each iteration, we are checking that if our second set size equals to 5, and consonants that we have got till now equals to k, that means this would be a valid substring that we are iterating over and will simply increment our answer. But if, for example, if we are iterating over this, if we are if we are iterating over this substring, simply we are iterating over this substring, and we have reached till now. So this is a valid substring, so our answer will be incremented. But in the next iteration, if we reach up to from here, if we reach up to this till the second q, so here the consonant value will be greater than k, right? Because in this it would be 2. So we'll simply break out of the loop and we'll start from the new iteration. So at last we'll simply return our answer. So this was a simple one. Now let us move to the second problem, which is similar problem, just the constraints are different. So now let us move to the next problem. The next problem is similar to the previous problem only, no differences there. Just the difference is of the constraints. In the previous problem, the constraints were smaller. So we could apply a double loop, like the double nested loop. But in this case, we cannot apply a nested loop because it will give us a TLE. So what we can do, since we can iterate over this given string only once, so for calculating the number of consonants, what we can do, we can calculate a prefix sum array of the number of consonants. It will only calculate the number of consonants. How? Let's suppose we are standing over this index. Now it will calculate this prefix sum array will calculate that how much consonants we have got till this index. So in this case, if you see, if we start iterating from index 0, so initially it would be 0, 0, 0, 0 like this. And if when we have reached till this index, the number of consonant would be incremented by 1. And similarly, if we move forward and if we are standing over this index, then the number of consonant will become 2, right? It will calculate that how much number of consonants we have got till this index, right? After this, what we can do, we can check over the by iterating over the string, that if we are if our given condition is satisfying, that if our vowels equals to 5 and our number of consonants that is equals to k, then we can say that yes, it is a valid substring, right? If our number of consonants equals to the prefix sum array, then yes, it is a valid substring. So if we directly look at the code, then you will get a better understanding of how the things are working. Initially, what we are doing, that we have taken a prefix sum array that will store the prefix sum of the number of consonants. So initially, we are iterating over the string only, and it is starting from 0, and our prefix sum array will contain the number of consonants, and here we are checking that if our given character is equals to consonant or not. If it is a consonant, then only we are adding, and if not, then we are simply adding a 0. Next, what we are calculating, we are taking a maximum consonants in some integer variable. Next, we are storing the range of the prefix sum that we have calculated. For example, if our prefix sum array was something like this, and the next vector would contain the range, like for 0, it will contain all the range that are containing the prefix sum equals to 0. That means if it is starting from 0, 1, 2, 3, 4, 5 like this, so it will contain the range, like it will contain the vector of 0, 1, 2, 3 like that. Similarly, in this case, our prefix sum would go from 2 to, again, it would be something like, here you can say it is a vowel, it is not a consonant. So our prefix sum would go like 0. Let's suppose if we draw it here. In this case, if we suppose initially it was 0, 0, 0, 0, then 1, then 2, 2, 2, like that. So it will store 1 also, and it will store the range. So if it was 0, 1, 2, 3, 4, 5, 6, 7, 8, like that. So it will store the range. So here 1 is only coming once, so it will store 5. Next, it will store the range for 2 also. So if we suppose 2 is starting from 6, it is going till 8 and after that also. So it is storing this. Next, this is the main logic here in which we are actually calculating the number of substrings. In this, we are simply iterating over the given string. Then we are storing it in the first character. We are storing in it a character variable. Then we are checking that if our given character is a vowel or not. So here we are storing the index of this vowel occurring in some another vector as well. So this is a vector, another vector that will store the first occurrence, or you can say the occurrence and the index of the vowels. It will store the vowels. Next, this is a condition where it is checking that if our not initially, that if on the character that we are standing is equals to vowel or not, means if, since it is checking that it is not it should not be equals to -1. Initially we initialized this equals to -1. So here it is checking that if all the values present, initially it was like this, and next it is checking that if all the values present in this vector is not equals to -1, that means yes, we have our vowels equals to 5. First condition is satisfied, right? Next, it is checking that if and we have stored the minimum index of the vowel. Like here, if we can say our vector can be 0, 1, 2, like that. Out of that, we will take the initial or the minimum value of the vowel. So let's suppose we are taking it as 0. Now, this, what we are doing. This is the, like, if, since we are calculating the prefix sum array, right? And we know that if we have to calculate that how many consonants we have got till this index, so we do like and from here to here we need to calculate that from this index. Let's suppose this is J, this is I. So we need to calculate that how many consonants are there in this range. So what we do, we simply do prefix of I minus prefix of j, right? Now, to make this condition equals to k, what we can do, we can write this equation like this, because at last we need to satisfy that our consonant, the number of consonants till this index should be equal to k only. That after that only we can make a valid substring, right? So it can be written like this, and after arranging it further, it can be written like prefix, because here we don't know prefix of j. We don't know this. We know k, we know I. So to calculate the prefix of j, what we can do, we can just rearrange this equation and we can simply write it like this: prefix of j, right? So this is done in this statement only. Here we are taking it as a target. Next, what we are checking is that if our this target should be in our range only. That means it should not exceed our boundaries. That is, it should be greater than 0 and it should be less than equal to the maximum consonants. What was the maximum consonants? It was the last uh, value of the prefix sum that we calculated, right? It will give us the maximum consonants that we have got in a particular string. So this would be the, if we are considering this as our final prefix sum array of the consonants, so this will give us a value of the maximum consonants. That yes, this much consonants are present in this particular string. Next, what we are doing in this, that we are taking the sequence that we stored earlier, like here, we are taking a full sequence initially at each iteration. Let's suppose at index number 0, our full sequence will come in some vector. Let's suppose the vector was 1, 2, right? Next, we are operating a binary search here, and we are calculating the upper bound for the binary search. That means, and we are calculating the range basically. Initially, we stored min last. Uh, Initially, we stored position min last as well, and we are calculating the sequence by subtracting it from the position list dot begin. Means if this is our initial position, and then we are applying binary search on this, and whatever the answer will be, will get our range, right? And if it is a valid range, yes, it is a valid range because we have checked all the conditions. So simply we are adding this in our answer. So at last we'll get the answer that yes, from this range to this range, after performing the binary search, that yes, from this range to this range, this much valid substance are present. So we'll store it in the answer variable and at last we'll return the answer. So I hope you have understood this. Thank you so much.